Dear class 10 student, welcome back. We'll continue periodic classification of elements, that is chapter 5. Today we will do the in-text question of page 90. Okay, the first question is, how could the modern periodic table remove various anomalies of Mendeleev periodic table? Okay, the confusions. Anomalies means confusions of Mendeleev periodic tables. So, the various anomalies of Mendeleev periodic tables are: Mendeleev was unable to give fixed position to hydrogen in his periodic table. He was unable to give fixed position to hydrogen. Okay. Isotopes of all elements posed a challenge to Mendeleev periodic table, periodic law. At that time, isotopes were not discovered. That is why it posed challenge to Mendeleev's periodic law. Some elements with similar properties were placed in different groups, and those with dissimilar properties were placed in the same group. Example, tellurium, that is atomic mass is 127.6, was placed in 6th group, but iodine, whose mass is less, that is 127, was placed in group 7. Okay, so let us go to the periodic table of Mendeleev periodic table. Let's find out. See here, tellurium in group 6, its atomic mass is 127, and iodine is 126.9, which iodine's atomic mass is iodine atomic mass is less than tellurium, which violates the periodicity of the periodic table of Mendeleev periodic table. Okay, according to Mendeleev periodic table, they were periodic function of atomic mass. So if you go across the period of the table, it should increase, not decrease. Okay. Similarly, cobalt was atomic mass of cobalt is 58.93 and nickel is 58.71, which is less than nickel. So cobalt, the atomic mass of nickel, cobalt is less than nickel, but it is placed after cobalt. So there is a confusion here also. Okay, so it was not periodic. It contradicts the periodicity of the Mendeleev periodic table. Okay. So it was iodine 127 was placed in 7. Similarly, elements with higher atomic weights were placed before lower atomic weights based on their properties in contradiction to his periodic law. Example, cobalt atomic mass 58.93, whereas nickel is 58.71. Okay, it was all this anomaly was removed by modern periodic table. It was Henry Moseley who demonstrated that atomic number of an element could explain periodic properties in better way than atomic mass of an element, and arranged the elements in increasing order of their atomic numbers. Then it was found that the various anomalies of Mendeleev periodic were removed by the modern periodic table. Now we go to section. Name 2 elements you would expect to show chemical reaction similar to manganese. What is the basis of your choice? So, name any 2 elements expect to show chemical reaction similar to manganese. Well, let's go to the periodic table. Okay, it's the predictable. Okay, here we are having the. So the question was that name two element expect to show chemical reaction similar to magnesium. So let us go to the predictable again. So let us here magnesium, below magnesium, that is calcium and strontium. Okay, they show similar property with magnesium. Okay, because all are in the same group, hence their valence is also same. Calcium and strontium are expected to show chemical reaction similar to magnesium. This is because the number of valence electron is 2 is same in all these three elements, and since chemical properties are due to due to valence electron, they show same chemical reaction. Now let's go to question number 3. Name 3 elements that have a single electron in their outermost shell. So lithium, sodium, potassium have single electron in their outermost shell. 2 elements that have 2 electrons in their outermost shell. So magnesium and calcium have 2 electrons in their outermost shell. 3 elements with filled at outermost shell. So neon, argon, xenon have filled outermost, means they have 8 electrons in their outermost shell. Okay. Question number 4. Lithium, sodium, potassium are all metals that reacts with water to liberate hydrogen gas. Is there any similarity in atom of these elements? Okay. Yes, the atoms of all the 3 elements, lithium, sodium, potassium, have one electron in their outermost shell. Now let's go to question number. Helium is an unreactive gas and neon a gas of extremely low reactivity. What, if anything, do their atom have in common? Means both of them, K shell is filled and L shell is also filled. Means that is K shell have 2 electrons. That is the first shell, K shell will have 2 electrons, and the other shell will have 8 electrons. So L shell is also the neon has 8 shell in the outermost orbit. So it is filled. In the modern predictor, which are the metals among the first 10 elements? So let us go to the predictable again. So here from hydrogen to neon are the 10 elements. Here all neon, fluorine, oxygen, nitrogen, carbon, hydrogen, boron, beryllium and lithium are the only metals. Hydrogen is also gas and helium is also gas. By considering their position in the predictable, which one of the following elements would you expect to have maximum metallic characteristics? So, gallium, germanium, arsenic, selenium, barium, beryllium. Okay. Since Be lies in the extreme left hand side of the predictable, beryllium is most metallic among the given elements. Let's check out. See here, beryllium is in the left side of the predictable, which are metal, and others like germanium, arsenic and selenium. Okay, gallium, germanium, arsenic and selenium. So gallium is germanium, Germanium is metalloid, arsenic is metalloid, and selenium is non-metal. Here you see non-metals are yellow color. So this is yellow. And so these are non-metals. All germanium, arsenic, selenium are non-metals. Only metal is beryllium. Okay. Now let's go to question number. Okay, we have completed the in-text question. Now we go to exercise. That is, go to page number 91. Which of the following statement is not a correct statement? About the trend when going from left to right across the period of the predictable, the elements become less metallic in nature. It is true. The number of valence electron increases. It is also true when we go from left to right in a predictable, at number of electrons, valence electrons increases. The atom loses their electron more easily. No, it is not true, because when we go from left to right, electron increases. Okay, when it comes to halogen or carbon, it does not easily releases the electron. It accepts the electrons. Okay, the oxides become more acidic. It is also true. Okay, so only false is the atomic lose their electrons more easily. Now let's go to question number 2. Element X form a chloride with the formula XCl2, which is a solid with a high melting point. X would you likely be in the same group of predictable as Na, Mg, Al, Si. Since sodium's valency is 1, magnesium is 2, aluminum is 3, and silicon is 4. So the compound form XCl2 will be magnesium only. Okay, X would be likely to same group. So okay, X would most likely to be in the same group of the predictable as magnesium. Okay. Now go to question number 3. Which element has 2 shells, both of which are completely filled with electrons? Okay, neon, whose electronic configuration is 2,8, is completely filled. Okay. Number B, the electron configuration 282. So the electronic configuration with elements with configuration 282, magnesium has the electronic configuration whose electronic configuration is 282. Okay. Now a total of 2 shells with 3 electrons in its valence shell. Silicon, whose electron configuration is 282. So it is silicon. Okay. C. A total of 3 shells. So here 1, 2, 3 shells with 4 electron. So B is neon. Okay, B is magnesium, and a total number of 3 shells with 4 electron in its valence shell. So C will be silicon, whose electronic configuration 284. So it has 3 shells and valence shells has 4 electrons. Boron. Now question number D. What is that? A total of 2 shells with 3 electrons in its valence shell. So boron, whose electronic configuration is 2, 3, has 3 electron. Okay, so its outermost orbit it has 3 electron. Carbon, whose electronic configuration is 2, 4, twice as many. Okay, we will do this. Twice as many electrons in the second shell as it is in its first shell. Okay, so in the first shell it has got 2, and the twice is it double, that is 4. So it is carbon. Now we go to question number 4. What property all the elements in the same column of periodic table as boron have in common? All the elements, answer is all the elements in the same column as boron have the same number of valence electron, 3, hence their valency is 3. What property do all the elements in the same column of periodic table as fluorine have in common? So all the elements in the same column as fluorine have the same number of valence electron, that is 7. Hence their valency is equal to 1. Question number 5. An atom has electronic configuration 287. What is the atomic number of this element? So atomic number means what? Number of proton. But in a neutral elements, number of proton is equal to number of electrons. So number of atomic number will be 2 plus 8, 10 plus 7, 17. Okay. To which of the following element would it be chemically similar? So atomic numbers are given in the parenthesis. Okay. Nitrogen, it is 7. Its electronic configuration will be 2,5. So it is not similar to the atom above said atom. Okay. Fluorine, it has 2, 7, means outermost orbit have 7 electrons. So it is similar to the above mentioned atom. Okay, 287. 15 and argon are atomic mass of atomic number of fluorine, phosphorus and argon are, it has got in the outermost orbit, in the phosphorus outermost orbits have 3, argon has 8. Okay, so they are not similar. Only answer is fluorine 9 with configuration 2,7 is similar. Question number 6. The position of the 3 elements A, B, C in the periodic tables are shown below. Okay, in the group 17 we have B atom, and group 17 we have A atom and C atom. Okay. State whether A is a metal or non-metal. Since it is in group 16, that means it has 286. Okay. Its electronic configurations are outermost orbit we have 6 electrons. Okay. Let's check it out. B, boron have 5 electrons. Okay. 5, 13, 2, 3. Okay, 3 electrons. 3 electrons in the outermost shell. Boron, huh? Group 16. Okay, no, it is not boron, it is B. Okay, sorry. B16 means 16 means it is in the group of, in this group. Okay, 16 in this group. So it outermost orbit will have 6 electron. Okay, it will have in this group 6 electrons. So it is not a metal, since it will accept electrons. Even 17, it is a halogen group. It is a halogen group and it has got 7 electron in the outermost orbit. Even C has also 7 electron in the outermost orbit. So since reactivity decreases if you go down the group, so the reactivity of A will be more than C. So A is a non-metal, C is less reactive than A as reactive decreases down the group in a halogen. C will be smaller in size. Okay, which will C be larger or smaller in size than B? Okay, next question. Since here in A element has one less shell than B. Okay, So A will be smaller in size than B, and C will be, since the number of electrons in C is more than the number of electrons in B, so the size of C atom will be smaller, because number of protons and number of electrons are more in C than B. Okay. Which type of ion, cation or anion will be formed by the element A? Since its outermost orbit have 7 electrons, so if it gets 1 electron, its octet is complete. So it will form an anion. Okay, it will form an anion as it accepts an electron to complete its octet. Now we go to question number 7. Nitrogen atomic number 7 and phosphorus atomic number 15 belongs to the group 15 of the periodic table. Write the electronic configuration of these two elements. Which of these will be more electronegative? Why? Okay. The nitrogen electronic configuration is 2,5 and the phosphorus is 2,8,5. Since electronegativity decreases as we go down the, nitrogen is more reactive than phosphorus. On moving down the group, the number of shell increases. Therefore, the valence electron move away from the nucleus and the effective nuclear charges decreases. So this causes the decrease in tendency to attract electron, and hence electronegativity decreases. Now let's go to question number 8. How does the electronic configuration of an atom relate to its position in modern periodic table? How does the electronic configuration of atom relate to its position in the modern periodic table? In modern periodic table, atoms with similar electronic configuration are placed in same column in a group. Okay. Column, that is group. Okay. In a group, the number of valence electrons remains the same. Elements across a period shows an increase in number of valence electrons. Question 9. In modern periodic table, calcium atomic number 20 is surrounded by element with atomic number 12, 19, 21 and 38. Which of these have physical and chemical properties resembles calcium? I mean, the valency of the atom with valency equal to calcium will have the similar property. So here the electronic configuration of calcium is 2882 and the electronic configuration of atom with atomic number 12 is 282. So this atom with electronic configuration, atomic number 12 will have similar property with calcium. Okay. Now let's go to question number, this was question number 9. Okay. Now we go to question number 10. Compare and contrast the arrangement of the element in modern Mendeleev periodic table and the modern periodic table. Okay, we'll make the table like this: Mendeleev periodic table and modern periodic table. Okay, in the Mendeleev periodic table, elements are arranged in the increasing order of their atomic masses, whereas in modern periodic table, elements are arranged in the increasing order of their atomic numbers. There are a total of 7 groups, that is columns, and 6 periods, that is rows. Okay, in Mendeleev periodic table, whereas there are total of 18 groups, columns, and 7 periods, rows. Okay. Number 3, elements having similar properties were placed directly under one another. Okay. Whereas in modern periodic table, elements having the same valence shell are present in the same period, while elements having the same number of valence electrons are present in the same group. The position of hydrogen in Mendeleev periodic tables could not be explained. Hydrogen is placed above the alkali metals. Okay, no distinguishing position for metals and non-metals. So we cannot know. We won't be able to know metals and non-metals in Mendeleev periodic table because it is not classified. Whereas metals and non-metals are at the left and hand side of the metals are present at the left hand side of the periodic table. Okay, periodic table. Okay, so metals are present at the left hand side of the periodic table, whereas non-metals are present at the right hand side of the periodic table. Right hand side of the periodic table. So we have completed this chapter totally. Thank you very much. We'll go for another chapter in the next session.